Use the graph of y1 is equal to x minus 5 to solve each equation or inequality. In part 1, we're asked to solve the equation y1 is equal to 0. In order to solve this equation, what we need to do is to locate all the points on the graph of y1 equals x minus 5 that have a y-coordinate of 0. Well, if a point has a y-coordinate of 0, then that point must lie right along the x-axis. And so we find the point on the line that intersects the x-axis, and that point is here. And the coordinates of this point are 5 and 0. The x-coordinate is 5, the y-coordinate is 0. So the solution set to the equation y1 equals 0 is the set of x such that x is equal to the number 5. And the way that we can check this with our equation is just to make a table of values. Put x and then y1. When x is 5, our equation says that we need to take the x value and subtract 5. So we substitute 5 for x and take away 5, and 5 minus 5 is 0. So when x is equal to 5, y1 is equal to 0. In part 2, we're asked to solve the inequality y1 is less than 0. So to solve this inequality, what we need to do is to locate all the points on the line that have a y-coordinate that is less than 0. Well, if a point has a y-coordinate that is less than 0, then that point has to be below the x-axis. So what we want to do is to locate all the points on the line that have a y-coordinate that is less than 0. All the points on the line that are below the x-axis. So where are all these points? Well, notice that all the points are to the left of the point 5, 0. So if we locate the x values of all these points, all of them have x values that lie along the x-axis to the left of 5. So we need to think of an inequality that describes the x values that are to the left of 5. And the inequality that describes those values of x is less than 5. So the solution set is the set of x such that x is less than 5. Again, if we want to check our results using the equation, we could make a table of values. We would pick some values of x that are less than 5 and then evaluate y1. So if x is less than 5, we're including numbers like 4, 3, and 2. And when x is equal to 4, 4 minus 5 is equal to negative 1. 3 minus 5 is equal to negative 2. 2 minus 5 is equal to negative 3. Notice that all the y1 values are less than 0. So the solution set is, once again, the set of x such that x is less than 5. Finally, in part 3, we're asked to solve the inequality y1 is greater than 0. So what we need to do is we need to locate all the points on the graph of y1 equals x minus 5 that have a y coordinate that is greater than 0. Well, if a point has a y coordinate that is greater than 0, then that point is above the x-axis. So some of the points that will work will be the ones that I'm highlighting right now. And we notice that all these points are to the right of the point 5, 0. So I'm going to highlight the x values that are to the right of the point 5, 0. And what we need to do is to think of an inequality that describes these values of x. Well, since the values of x are to the right of 5, the value of x must be greater than 5. So the solution set is the set of x such that x is greater than 5. In order to check our results, we can make another table of values. Pick some x values that are bigger than 5 and calculate the corresponding y value. Some numbers that are bigger than 5 are 6, 7, and 8. If we substitute 6 into the formula, we get 6 minus 5 is 1, 7 minus 5 is 2, 8 minus 5 is 3. Notice that all the y values are greater than 0, and this supports the fact that the solution set is the set of x such that x is greater than 5.